Okay, so these notes are the second part of section 4.1, sampling and surveys. We're going to look at a couple of different types of random sampling. So we talked about simple random sample last class, and so now we'll talk about stratifying random sample and a clustered random samples. Sometimes it's more advantageous to use these. It will sometimes, for stratifying, it will sometimes guarantee a more representative sample. Clustering is often used because it's just simpler to do. All right, so a stratified random sample. The basic idea is that you, if you take a simple random sample from the entire population, you might get certain subgroups in the population that are more represented than others, or some might be underrepresented. And so we will sometimes use a more complicated sampling called stratified. So a stratified random sample, first you're going to break the population up into subgroups, or what we refer to as strata. So everyone in those subgroups should be similar in some way, like maybe age, right? So I don't want to just take a simple random sample of the population because I may not get enough old people in my survey or in my sample. And so I might break the population up into groups by younger people, middle-aged people, and then older people. And then make sure that I have appropriate numbers from each group. That way, one of those groups is not underrepresented or overrepresented in my sample. So here's an example. So the knitting club is kind of a silly example, but let's say we have 12 freshmen, 18 sophomores, and 6 juniors in this club. And the club sponsor wants to survey a sample of students to see if they're going to attend the National Knitting Convention this year. So he wants to survey 6 students. So how can this be done? So we would look at, okay, 6, right? And so how many people are in the entire population? It looks like 36. And so we want a representative sample from each. So 36, 6 of them are juniors, right? So that means 1/6 of the population, the knitting club, is juniors. So we need 1/6 of our sample to be juniors. So again, we kept this one simple and made the math pretty easy. But 1/6 of our population is juniors, so 1/6 of our sample should be juniors. So that means one of our juniors will be randomly selected, and they will be part of our sample. So we're going to do an SRS of just juniors and pick one. And then if we look at freshmen, there's 12, right? So if we think about 12 is 2/6 or 1/3 of our population of 36 students. So that means 1/3 of our sample should be freshmen. So we do an SRS. We choose 2 freshmen. That would be 1/3 of our 6 sample size. And so do an SRS of just freshmen, and we choose 2 of them. And then if we move on to sophomore, there's 18. So that means 1/2 of our population is sophomores. 1/2 of our sample should be sophomores. So 1/2 of 6 is 3. So we do a third SRS. We do one just of sophomores, and we ask, and we get 3 sophomores. So we'll have 1 junior, 2 freshmen, and 3 sophomores. Now this worked nice because the example we gave had all numbers divisible by 6, and it was easy. If we wanted 8 students in our sample, then we'd have to fudge some numbers, but we kept it simple here. And most of the time, when you're asked to do a stratified in this class, it'll be sort of simple as well. And so here's another example of a stratified. So an owner of an engineering firm wants to survey employees about whether he should start a daycare center down in the lobby of the building so that people could bring their kids to work, drop them off at the daycare center, and then go upstairs to their cubicle or to their desk and work. Okay, so let's assume also that 30% of our in engineering employees are female and 70% are male. All right, and then we want to sample 10 employees and ask them, hey, should we start a daycare center? So what might be an issue here if we don't use a stratified random sample? If we just use an SRS of 10, what would happen if all of my samples, just by chance, all of the 10 that I sample are male? So men tend to not be the members of the family that tend to more often than not aren't responsible for the upbringing of children, or less often, let's say. And so let's say that those males that I ask aren't responsible for taking care of the children at home. And so they may not be interested in a daycare center. They don't want to bring their kids to work with them. And so maybe if by chance I just happen to randomly pick 10 people and they're all males, then they might say that, yeah, we're not interested. And so as a result, the owner might say, oh, I surveyed people and no one seems to be interested in a daycare center. And so he may not open a daycare center that actually might be of use to the employees and their children. The other thing that might happen is, what if by dumb luck I got all females, or the females are overly represented in this sample of 10 employees? Then they might be more interested in having daycare in the building. And so then the owner looks and says, oh, look, a lot of people in the survey are interested in daycare center. He may pay to have a daycare center constructed. He might hire staff, go through a lot of expense. But as it turns out, the sample was overly represented by females more than the population. And so maybe the daycare center is underutilized. And so as it turns out, he's wasting his money putting together a daycare center that nobody tends to use. So both of these, right, would possibly be a bad situation. And so this is where a stratified random sample would come in. So let's say, again, I'm going to do a stratified random sample. How many females should be part of my sample and how many males should be part of our sample? So the females, 30% of the employees are female, 70% are male. Those same percentages should be in our sample. So 30% of our 10 should be female. So that means 3. So I do a simple random sample of just the females. I take all the females' names, put them in a list, number them, and then I randomly pick 3. And then I do the same thing for the males. I do a simple random sample of just males. I take all the males, put them in a list, number them, randomly pick how many? 70% of the 10, or 7. That gives me a total sample size of 10. But the proportion of females in my sample should equal the proportion of females in my population. The proportion of males in my sample should equal the proportion of males in my population. All right, so our next type of sampling is a cluster sample. So a stratified is used. You use groups in Stratify, but we use it to make sure that we have a more representative population, right? So that we have enough males in the sample and enough females in the sample, like we did in the last example. Here we're going to use groups. Now these groups are sort of, when we say clustered, it means they're really kind of grouped together already. And the example, you'll see what we mean. So here the groups. Each group is heterogeneous, so the group is all different people in the group, and it's sort of a naturally occurring group, as opposed to the stratified, where everyone in each group or strata is homogeneous. So we have all the old people in one group, the middle-aged people in another group, the young people in another group. Each of those groups are homogeneous. Here, each group is kind of identical from group to group to group, and so each of the groups is more heterogeneous. All right, so to get a cluster sample, we first identify the population that are, and they're broken into groups, and these groups are called clusters. All right, and we do an SRS to pick an entire group or groups. So, and then we go to that group, and everybody in the group, all members of the group, are sampled. So we're not randomly sampling within the group, we're randomly sampling or choosing randomly a group or maybe two groups or three groups. And then everyone in that group is part of our sample and gets surveyed. So for example, during homeroom next week, the freshman counselors want to survey randomly survey a sample of the 500 freshmen. So let's assume we have 500 freshmen, and these 500 freshmen are spread over 20 different homerooms. So during homeroom next week, the counselors will randomly pick maybe one, maybe two, depending on how many they want to sample, but let's say they sample 2 classrooms. So they go and they randomly choose, using an SRS, 2 of the 20 classrooms or homerooms. And then what they do is they go to those 2 selected homerooms, and everyone in that homeroom or in that class gets a survey. Okay, and this is called clustering. All right, so here is an example. On the west side of the Rocky Mountains National Park, many mature pine trees are dying due to an infestation of pine beetles. Scientists would like to use sampling to estimate the proportion of all pine trees in the area that are affected or infested with these pine beetles. So we don't have the ability to go look at every single tree. So we're going to, that would cost too much money. It would take too much time. So we're going to do a sample. All right, so explain why it's not practical to do an SRS in this case. So think about what an SRS would be, right? So what's the first thing we do with an SRS? We take the population and we number it from 1 to whatever, right? So that means each one of these trees would have to be identified and numbered. So we're talking about millions of trees. So it would be inconceivable to do an SRS here. It would just take too much time to number all of the trees. All right, so one possible, part B then, a possible alternative is let's just go along the main road and we'll look at trees that are next to the main road. Is that good, or why is this sampling sort of bias? So it could be that, the trees next to the road have to deal with a lot of carbon monoxide from cars, carbon dioxide from cars, and so maybe those trees are not as healthy. And so since they're not as healthy, maybe it's easier for the pine beetles to attack them, right? So what would happen if we use them as a sample? We might think, oh my gosh, the proportion of trees that are infected are much larger than they really are, and we might throw resources at this problem, which might not actually exist. The proportion of infected trees may not be as high as it is along the road, because the trees on the road, along the road, might not be as healthy, right? Their root system, are encumbered by the road or by truck traffic, whatever. They may not be a good representative sample of the entire population. All right, so what would be an appropriate method? I think if you think about it, if we took what kind of sampling was this in part B? And so I think that would probably be referred to as a convenient sample. So we just used a convenient group of trees and called them our sample, and that's no good. That would introduce bias. Our results would not be valid, I think. And so part C then, what would be an appropriate method? So what if we took a map of this area and we broke that map into equally sized areas? So, little rectangles, right? Each, maybe 1/10 of an acre or something like that. Maybe we would break it up into 1,000 different regions or areas. And then we randomly use an SRS to randomly select a number of these areas. And then we go using GPS, we would go to those areas and sample every tree in those areas, right? So maybe we sample 20 different plots of land. We go to each one of those plots and we look at every single tree and assess whether they are infested with beetles or not. Okay, so what kind of sampling would this be? And this would be the cluster, right? So we look at the clusters would be the groups, right, of trees, and then we randomly select cluster or clusters. Probably we would randomly select dozens of clusters and then go to each one of those clusters and sample every tree inside and see if it's infected. All right, so part D. Assume that we obtain a statistically valid sample and that 35% of the pine trees are infested with beetles. Can we say that 35% of all pine trees in the park are infested? Well, probably not, right? But the whole idea is we would hope that it would be close, right? The whole idea is to get a representative, randomly selected sample, and the proportion of infected trees, let's say it's 35, we would hope that that would represent or be close to the true proportion of trees in the park that are infected, which we would hope it would be close to 35. And then what could we do to ensure that we get a closer estimate, right? So one thing that we can do is we could increase our sample size. Now we're going to have limitations to how big our sample can be. We have certain rules and statistics, and we're going to eventually get to a point where we can't sample more than 10% of the population. It causes issues, and we'll talk about why and what later. So let's say we took a map of the park and we broke it up into, let's say, 500 little areas. Then we probably would not want to sample more than 50 of those for it to be valid. Okay, your homework for part 2 here is listed. This is due next class.